The advantage of using additive manufacturing at Swift Engineering is lead time, and lead time. Additive manufacturing impacts lead time in the sense that we can realize a part from design to production or fabrication of a part in one day even. We have the need for an easy way to remove tools from parts that were potentially trapped in a mold or a complex geometry with varying diameters. And additive manufacturing allows us to have tools that can be dissolved or it can be removed. The utilization of additive manufacturing in the context of composite fabrication begins with an idea which leads to a design in a CAD program. Once the design is complete, we have the tool 3D printed. Additive manufacturing allows us to have parts that have less seams, less post-production work. We're able to fabricate really complex geometries and gives us control of inner surfaces of parts that we might not have if we were using a multi-piece tool. After the tool has been 3D printed, we go straight into tool preparation, sanding of any anomalies, perfecting the surface finish, and then applying mold sealer on the tool. And then we would go into application of the mold release. The mold release that's applied allows for part separation after the part has been cured. The part lamination process begins with ply development, and he or she creates these patterns according to the geometries of each part. That allows the composite material to drape properly, to give the right fiber orientation, and to maintain it. That process is very tedious and very important. Once the lamination is complete, we go into the vacuum bagging process where we apply the FEP, the breather, the vacuum bag, and the vacuum sealant tape. We do our vacuum checks to verify that our vacuum bag is good and that there's no leak. The tool and the part is then loaded into an autoclave and the proper recipe is then loaded. Pressure is an important parameter that allows for compaction during the curing process with these laminates. So it's vital that we have a tool that's able to withstand pressures that is 85 or 90 psi. The permeable triangular pattern allows the Stratasys tools to have a backup structure that will be able to withstand the pressures and the temperatures of an autoclave cure. After the part is cured, the vacuum bagging materials are then discarded, and the tool and the part is now placed into a solvent bath for the dissolving of the tool. The solvent bath allows for a more simple and less messy setup when it comes to removing sacrificial tools. After the dissolving process, you have a finished product, which then can be bonded, trimmed, or drilled in the next level assembly. Some of the advantages with partnering with Stratasys is that Stratasys has engineers that have worked in the aerospace industry. They know composite fabrication. They have a vested interest in the industry and the know-how to support that industry.